T11.13. I can't get through my day without coffee is a common statement from many college students. They assume that the benefits of coffee include staying awake during lectures and remaining more alert during exams and tests. Students in a statistics class designed an experiment to measure memory retention with and without drinking a cup of coffee an hour before a test. This experiment took place on 2 different days in the same week, a Monday and a Wednesday. 10 students were used. Okay, so we have 10 students, and it was an experiment. Okay. Each student received no coffee or 1 cup of coffee an hour before the test on a particular day. The test consisted of a series of words flashed on a screen, after which the student had to write down as many of the words as possible. Now, on the other day, each student received a different amount of coffee, either none or 1 cup. Okay, so basically what I'm gathering from this is that this is a matched pairs design. Right. Each student actually received both treatments, so we have 2 measurements per student. You can see that in the table here, right? We have 2 measurements for student number 1, and there's 2 measurements for student number 10. So each student in the study has a pair of measurements, hence the name, matched pairs design. Right, part A. One of the researchers suggested that all the subjects in the experiment drink no coffee before Monday's test and 1 cup of coffee before Wednesday's test. Explain to the researcher why this is a bad idea and suggest a better method of deciding when each subject receives the 2 treatments. Okay. It's a bad idea because it's going to lead to confounding. Okay. Naturally, if you perform the same test twice in the same week, you're probably going to do better the second time around, right? Just because you're learning as you go. Also, there could be confounding with some event that may happen on either Monday or Wednesday, right? That could affect students' performance on this test. Okay. So yeah, we want to randomize the order in which the students receive the treatments. One way to randomize is to flip a coin. Right? So student 1 shows up, we flip a coin. Heads means they get no coffee, and then tails means they get 1 cup of coffee. And then the second time they come, we just give them the other treatment. Okay? Right, so that makes it random. All right, part B. The researchers actually used the better method of deciding when each subject receives the 2 treatments that you identified in part A. For each subject, the number of words recalled when drinking no coffee and when drinking 1 cup of coffee is recorded in the table. Carry out an appropriate test, so it's going to be a matched pairs t-test, to determine whether there is convincing evidence that drinking coffee improves memory on average for students like the ones in this study. Right, so here's what you do when you got pair data. You calculate the differences, right? And I'm going to do 1 cup minus no cup. Okay. Right. So student number 1 improved by 1. Student number 2 improved by 1. Student number 3 improved by 1. Student number 4 made no improvement. Student 5 improved by 1. Student 6 improved by 2. By 2, no improvement, and improved by 2. Okay. Take a look at that. Everything is either positive or there's a couple zeros there. All right, so next thing I'm going to do is enter this data into Stablet. All right, so I can just quickly get the mean and the SD and all that. Okay, 1 quantitative variable. Okay, difference in memory score. Okay, so we've got 1, 1, 1, 0, 1, 2, 2, 0, 0, 2. All right, look at that. Look how symmetric that is. Okay, so X bar is 1, S is 0.816, sample size is 10. Okay, no skewness, no outliers. Keep that in mind. All right, so let's go ahead and perform this test. So the choose step procedure, matched pairs t-test. Significance level, 5%. I don't know, did it say? Okay, we can pick. I'll choose 5%. All right, parameter. Mu diff is the notation, and it's going to represent the true mean difference in memory scores. 1 cup of coffee minus no cups of coffee. Right, our null hypothesis is mu diff equals 0, which is equivalent to saying that coffee has no effect. The alternative hypothesis is mu diff greater than 0, which is equivalent to saying that coffee improves memory. Okay. Right, our statistic, x bar diff, is 1. So for the 10 students in the study, on average, they improved their memory score by 1 word, or 1 point, I don't remember. And okay, so down 2, 3, 4, 5. Okay, so evidence for the alternative, sure, that's evidence. 1 is greater than 0. All right, let's check the conditions. So this is an experiment, and we said that we would use random assignment. Okay, so this is check. Random assignment, check. All right, 10% rule does not apply for experiments. Okay, only applies when you're sampling. Okay, remember I said keep in mind this dot plot. So because our sample size is small, right, it's less than 30, we can't use central limit theorem to satisfy that last condition. So we're going to look at the sample data, and yeah, no strong skew, no outliers. Sample data show no strong skew or outliers. Check. All right, let's use this space over here. All right, calculate. All right, so we're going to do a standardized test statistic. Statistic minus parameter over an SD. Right, this is going to be a t-score. X bar diff is the statistic. Mu diff is the parameter. S diff over root n, or n diff, is the SD. Okay. Now, I might have mentioned this in class. Whether you write the subscript diff or not does not matter. The mechanics, the calculation you get is going to be the same. Right? It's just labeling, really. Okay. X bar diff, that's 1. Mu diff, 0, right, according to the null hypothesis. All right, S diff is 0.816, and our sample size was 10. Okay, so let's see. Fraction 1 minus 0, another fraction, 0.816 over root 10. Okay, test statistic is 3.88. I'll round it. Okay. All right, let's draw a t-distribution with degrees of freedom 9, right? Remember, n minus 1. Okay, our standardized test statistic is 3.88, which would be pretty far out in the right tail, and we're going to shade the area to the right. Okay. And I'm going to use tcdf to find that area. So lower bound 3.88, upper bound 999, degrees of freedom 9. Okay, our p-value is 0.0019. Okay, now since that value, 0.0019, is less than 5%, the results are statistically significant. We reject the null hypothesis. Okay, so we do have convincing evidence that, okay, now the context. Okay, I'm just going to borrow from the question stem. We have convincing evidence that drinking coffee improves memory on average for students like the ones in the study. All right, I'm feeling pretty lazy. I'm just going to copy and paste that context. Okay, copy image, screenshot, I guess. Paste, move it down here. All right, so since 0.0019 less than 5%, we reject the null. We have convincing evidence that drinking coffee improves memory on average for students like the ones in the study.